Yes, good afternoon, students. Yes, good afternoon, student. Yes, please check my voice is audible.
Yes, sir, it's audible.
Audible. Okay, wait, ma. Again, I will share my screen. Please check whether it is visible or not. Yes, now PPT is visible.
Yes, sir, it's visible now.
Okay, thank you. Okay, only
Excuse me, sir.
yeah. Tell me
Sir,
now.
can you share the previous class video lecture, sir? Previous one.
Uh, Lecture video. I don't know whether I have. Okay, if I have, I'll send it.
Yeah, okay, fine. Sir.
Okay. Yes. Only 6 members. 5 members are there. Okay, shall I start? So we will wait another 2 minutes. Only 6 members are there. Okay. So after 2 minutes, we'll start. Okay. Yes, good afternoon, student. So last class we discussed about a part program on a drilling operation, right? So as you know that the drilling operation, drilling is nothing but it's a process of producing a hole, right? Yes, please check my voice is audible. Yes, please check my
Yes,
voice is
sir.
audible.
Yes, sir.
Yes, PPT is also visible.
Yes, sir.
Okay, thank you, ma'am. Yeah, last class we discussed about the part program and drilling operation. Drilling is nothing but it's a process of producing a hole on a workpiece. There are so many drilling operations out there. First, you go for producing a hole that called as a drilling, or enlarging a hole called as a boring, or you go for enlarging a hole only on one side of the drilled hole called as a counter boring, right? Or if you want to make a helix form which is already drilled hole, that is called as a tapping, right? So if you want to finish the hole, that called as a reaming operation. Those are the drilling operations. So last class we started how to produce a hole on a workpiece. The same what we use a end milling operation only, end milling machine only, by using a conventional method. Conventional method means this is a workpiece. You can see that just Move the cutting tool from home position to the where the location of hole you want to produce. There cutting tool will move there, then give a feed and out feed. Then move the second location, again give a feed, out feed, right? This is the way you can do the drilling operation. That is called as a conventional drilling operation. Right? This is how we write the manual part program using a conventional drilling operation, right? This is how we write first. As you know that first five lines are same for all the program. What are the first five lines? First one is a name of the program, that is followed by the letter O, followed by four-digit number. Next, initial G codes. Initial G codes are first G90. G90 stands for what? Whatever the coordinates we are measuring, location coordinates we are measuring with respect to what? Horizon. Bottom left corner is the horizon always we take. So whatever the coordinates we can measure here, that in the whole, the coordinates always we measure the coordinates with respect to horizon. That is called as a G90, absolute coordinate system. Next, G21. G21 stands for what? The input values are in millimeter. So if you measure the coordinates, location for the first wall with respect to horizon, how many in x coordinates how much, y coordinates how much, how do you measure it in millimeter? All dimensions are in millimeter. That's the input values are in millimeter. That is G94 stands for what? Feed rate in mm per minute. Right? These are called as second line shows it is a initial G codes. After that, now the cutting tool is somewhere in the home position. Now we'll go for select the cutting tool for corresponding drill bit. We go for select the cutting tool, that is M06. M06 stands for what? Select the tool or change the tool. What is the tool we are going to select here? T01. For T01 stands for what? So manually the operator has to give the input. That is for example for this operation this is a drill hole is 6 mm, means 6 mm the HSS drill bit we are going to choose there. Once you choose the cutting tool, then you go for start the rotate the spindle in clockwise direction, counterclockwise direction based on the M codes. Here M03, rotate the spindle in clockwise direction, that is M03. Whenever the spindle rotates, you should give the speed and feed. What is the speed here? 1500 rpm. Speed is 40 rpm. 40 mm per minute. Sorry, 40 mm per minute. Now move the tool from home position of the machine to the horizon origin of the workpiece. There is a bottom left corner is here. Have it chosen here. Bottom left corner is the origin. Now move the cutting tool from home position to the origin of the workpiece. For that, you have to give the G00, X0, Y0, Z2. These are the five initial G codes, right? Five initial means sorry. These five lines are common for all the program. It may be a milling program or drilling or turning program also. And last three lines are also common for last three four lines are also common here. So remove the depth, then send the tool to home position, stop the spindle, then stop the program and restart the program. Okay, these four lines are same for all the program. First five lines, last four lines. Okay. Then whenever the problem is given, how to write the manual part program? First you study the geometry, see the diamond, what type of motion it is, what type of motion it is, sorry, what type of program it is, then what type of operation it is a milling or drilling operation. Next, see the geometry. Next, we'll go for see the dimensions. Then we'll go for assign the coordinates, the coordinates for the each locations, right? Once you know the location for the each coordinates, each location, then you go for start write the program. Okay. And also last class we discussed about the cycles. Cycles means whenever the repetitive operations are there, then you go for call a cycle. This is what type of cycles are here? Scanned cycles. The scanned cycles are used to remove the stock removal of material from the work pieces. Right? There are how many cycles are there here? Drilling cycle. Drilling cycle starts from G80 to G86. G80 nothing but is a cancel the canned cycle. We start from G81. G81 stands for what? Drilling cycle. When you call the drilling cycle, if the depth of the hole is less than the diameter of the hole, then you go for call it a drilling cycle. Yes, I am repeating here. If the depth of the hole is smaller than the diameter of the hole, then you go for call a drilling cycle. What is the format for drilling cycle? G98 or G99, G81 or ZF. What is G98 means? Initially, before going to drilling, go for do the drilling operation. First, to move the cutting tool from home position to the workpiece origin to the initial location. That is what is the initial height is there. That is the what we call as initial point for the calendar cycle or initial height, safe height for the cycle. G98 or instead of using G98, you can use G99 also. Whenever G99 use, you should give the R value. R value should be any positive value. Means it's a reference value. This is also similar to a safe height. R point is nothing but return point or safe height. That is also you should give a positive value. After this, what is the drilling cycle code? Drilling cycle code is G81. Then R is a safe height or return point. Z is nothing but what is the depth of hole. What is the depth of hole? Then F is nothing but the feed rate in mm per minute. So when you use the drilling cycle, when the depth of hole is less than the diameter of the hole, then you go for call a drilling cycle. Next, after the counter boring cycle means counter bore means already you drilled a hole on one side will go for enlarged hole, right? That is called as a counter boring, right? This is a format we use. Generally, counter bore will not use. Next one, peg drill. That is important. Peg drill cycle. That is G83. See that when the depth of hole is greater than the diameter of the hole, then I want to produce a deep hole in the workpieces. Then how do you produce a deep hole in the workpieces? By calling a cycle, calendar cycle, a peg drill cycle G83. What is the block format? G98 bar G99. Any one code you can use here. G83 peg drill cycle code. R is a safe height or return amount is a positive value. Z is nothing but total depth of ore. Q is nothing but peck increment. What is a peck increment means? Suppose I want to produce a 20 hole, but what we consider here diameter of the drill bit is 10 So depth of hole is greater than the diameter of the hole, right? Now, so I want to produce a deep hole. And in one shot or in one flat, will not produce a deep hole. Then what we will do? First, you will give a effect increment 1 then remove the depth. Remove the depth. Again, give a depth another 1 remove the depth. Again, after how many times you want to produce a 20 depth of hole for 20 times. That is give a depth and remove the depth, give a depth and remove the depth, right? That is called as a peck increment we call as, or incremental depth we call as. Okay, that you should give in millimeter. Okay, next after the line F stands for what? Feet, right, in per minute. Then you go for, remember one more cycle very important is tapping cycle. So tapping cycle means I want to produce a thread here. So internal threads in the drilled hole. Then how do you produce? With the help of a tapping cycle G84. So what type of tapping here? It is a right hand tapping. Means if you turn the right hand, if you use the right hand, if you turn in clockwise direction, it is in feet. Okay, it will tighten. If you reverse in direction is counterclockwise, it will become, it move away from the workpiece, means is a loosening it. That is called as a right hand tapping. Now what is the block format? You can see the G98 or G99. What is the tapping cycle code is G84 or ZF. Again, R stands for safe height, Z stands for the depth of tap, depth of hole or depth of tap you can take. F is nothing but feed rate. But here feed rate don't directly write that. Whatever the problem is given that feed rate, that value should not take here. Then you go for, if you use the formula, you already know that in the turning operation in the lathe machine also how to set this the gear ratios. Okay, in that thread cutting operation, the same thing here also. But here the feed rate is F is equal to what? Feed rate in per minute. You go for calculate here. What is the formula we use? The spindle speed in RPM into the pitch of the thread. Pitch is nothing but the distance between two consecutive threads, right? Now then, suppose if you want to do the right hand tapping, the spindle direction for right hand tapping, you should rotate in clockwise direction, that is in feet. Counterclockwise direction it is out feet. Means the spindle should rotate in what direction it is? Clockwise direction. Right? M03 should on here. M03 should give that call. Now remember three operations you should remember. One is a drilling cycle. Second one is peck drilling cycle. Third one is tapping cycle. And one more, it is boring also there. It is similar to drilling also. Boring means enlarging a hole. G98 or G99. Only the G86 code will come. Remaining term is similar to the drilling cycle. RZF. So whenever you call the cycle, current cycle, you should cancel that current cycle. How do you cancel this? By giving a code is called as G80. Right? Now remember these five G codes for calendar cycle. One is G80, cancel the calendar cycle. G81, drilling cycle. G83, peg drilling cycle. G84, tapping cycle, right hand tapping. Then last one is G86, that is used for boring cycle. Right? So the last class also we discussed this is how we write the manual part program using without calendar cycle and with calendar cycle. Right? Now we'll take the next program. So take the next program in your notebook. Write down. Write a manual part program. Yes, write a manual part program for the following figure. Take 6 mm diameter HSS twist drill and comma M10 into 1.5 P means M stands for metric. Metric means that is used for here for tapping. It is metric unit. 10 mm tapping, it is diameter into 1.5 mm pitch P tap tool. Feed is 80 per minute and spindle speed is how much? 1200 rpm. So read the problem once or twice. Write a manual part program for the following figure. Take 6 mm diameter HSS twist drill. Second one, the tap tool is how much? 10 mm M10 into 1.5 P. Metric 10 mm 1.5 pitch it is. Tap tool. Then feed is how much? 80 per minute. And spindle speed is how much? 1200 rpm. Now we go for study this drawing. Now go for study this drawing. Now you can see that this is what we can see that a one square block is there of how much? 200 into 200. 200 x axis, 200 in y axis. Thickness is how much? 20 is there, right? So in the square block, you can see that the 8 holes are there. See that 8 holes are there. So what is the size of the hole here? M10 into 1.5 P, right? So means it is a tapping. It is right. Metric 10 into 1.5 pitch of the thread. And one more is given PCD 140. PCD means what? Pitch circle diameter 140 mm. Now from the center of the square block, now you can draw a radius 70 mm. Now it become diameter how much? 140 mm. Radius is 70. 70 into 2, 140 mm will get, right? So diameter become 140 mm. Then you draw a radius 70 mm. Then on the 70 see how many volts are there? 8 volts are there, right? Yeah. What is the depth of hole? Her depth of tap is given here 20 Depth of tap is 20 Then now study the geometry first. Okay. Then you go for study the dimension. All the dimensions are given or not. You check. The square block dimension is given. How much? The square block dimension is 200 Next, what is the diameter of the hole? It is M10 into, so what is the tapping? It is M10 into 1.5 P. What is where the tap here is located here with respect to from the center? It is what is the circle diameter? It is 140 diameter. Now convert into radius. From the center it is how much? It is 70 Now, so see the diagram, study the diagram, then check the unit. Then after that, now immediately go for say the how many operations are there here. Now earlier is given. Now first I want to produce a hole on the each location here, right? First I want to produce a hole. There's a first drilling operation. What is the drill bit is given? 6 drill bit is given, right? First you produce a hole 6 Now after this, then I want to directly go for tap 10 No, it's not possible. Then I'll go for boring. Boring from 6 mm to how much? 10 mm. Enlarge the diameter of the hole from 6 mm to 10 mm, right? Then after 10 mm, once you enlarge that hole, that is a boring operation, then you go for a tap it. What is the tapping? The diameter, the size is given m10 into 1.5 p. Okay, so now here three operations are there. One is drilling operation, second one is a boring operation, and third one is a tapping operation. Now we'll go for write the program according to the type, according to the type of operation, right? Yeah. After that, once you decide the type of operation, first you go for do the drilling, second boring, third one tapping. Now somewhere you can see this is a machining center point. Now you have to fix the workpiece origin. So how do you consider workpiece origin here? Always you go for consider the workpiece origin is bottom, left corner is the origin. Bottom, left corner is the origin. See the bottom, left corner is the origin. Now you can see the cursor here. This will be the origin of the workpiece x0, y0, z0. Right? Yes. Now whether I have a coordinates for the a location for the each hole. Yes, can we directly can determine the location of the coordinates for the location of the each hole? Yes, please unmute yourself. Then how do you determine the coordinates for each hole? X coordinate and y coordinate, right? Now again you go for apply your engineering drawing. Say how many holes are there? 8 holes are there. What total it is 360 degree. So I want to know the what is the angle between the each hole. Angle between the holes here. This is from the center to, for example, if you take from center, 1 minute. Okay. So from side, the what is the angle between the holes? So what is this included angle? How do you calculate this included angle? So what I am moving cursor is visible. Please give me response. Yes, please give me response. Now what is this angle? Yes. How do you determine angle between these holes? Okay. So total is the angle is how much? 360 degree divided by a number of holes. How many holes are there? 8 holes. 360 divided by 8. How much you got? 45 degree. Now you can see the next slide. Now you can see the next slide here. Now this is from the center to this center of the hole. It is distance is radius is how much? 70 mm. Now what is the angle between the hole? It is 45 degree. How do you get here? See that holes included the yeah holes included angle. The angle between the holes here included angle between the holes is equal to total the circle angle of the circle. It is 360 degree divided by number of holes. 360 divided by number of holes is 8. Now we will get 45 degree. So once you get the angle between these holes, it is 45 degree. Now we'll go for apply a trigonometric relations. What is the trigonometric relation? From the center of the block here, from the center of the block, this is what is center of the block here. From the origin it is 100 mm, x-axis 100 mm, y-axis, right? From the center of the block here, what is the radius of the each radius of the location of the hole here? It is 70 mm only because it's given this circle diameter is how much? 140 mm. Radius is how much? 70 mm. Means we know the hypotenuse is 70 mm. What is the angle between here? 45 degree. Now from the each center of the hole, draw a horizontal line and draw a one more is vertical line. Now will become what here is the right angle triangle. Once it is a right angle triangle, this hypotenuse is 70 mm, angle is 45 degree. Now you can easily calculate opposite side and adjacent side. What are the opposite sides comes here? See that the side which is opposite to the angle. So which trigonometric terms will come here? Sin theta means sin 45. The side which is adjacent to the angle, it is adjacent side, that is a cos theta will come. For cos theta, how do you determine that adjacent side? That is a hypotenuse into cos theta, that you can see here. Okay, that you can see here. Now this is what So 70 into cos 45 degree means that is what you can get here, adjacent side, right? Adjacent side it is, right? Now what is 70 into sine 45 degree? 70 into sine 45 degree, what side it is? That is opposite side. Just we'll go for add and subtract the opposite and adjacent side. That gives a location for the each hole. See the hole number, how many holes are there? Here I'll consider this is hole number 1, 2, 3, 4, 5, 6, 7, 8. Now I'll go for in counterclockwise direction. Sorry, clockwise direction. Sorry, make it correction. This is a clockwise direction. This is a hole number 1. Now what is the coordinates for hole number 1 with respect to origin? See that from the hole number 1 with respect to origin. Now what is the x-axis and what will be the y-axis? Yes. See the what is the from the origin, what will be the x-axis here? What is the x-axis here? Total is how much? Total it is 200 block. From the center it is 100. Okay, from this here to here it is 100 minus 70. From the center it is radius of the circle is how much? 70. 100 minus 70. What is the x value you got? X value you got? Is it 30? Am I right? Don't simply, so what I'm telling is simply don't blindly don't believe it. You check whether it is right or wrong. If you're not understood, please ask me the doubt. Okay, I'll try to clarify your doubt. Similarly, what is the vertical distance of the hole? See the total it is how much? 200. The first hole location is exactly at the center here, right? Y value is how much? Y value is 100. Am I right? Total 200. 200 divided by 2. Center exactly it is located at center. This is 100. See that the whole number 1. What is the x coordinates is 30. Y value is 100. Right? Is there any doubt regarding this? Please unmute yourself. If you have doubts, please ask me the doubt and I'll try to clarify your doubt. Yes? Just give me response.
Yes, sir. Understood, sir.
Understood. Okay. Now we go for similarly go for second hole. So what is the coordinates for second hole? Yes, anyone can tell me the what is the coordinates for the second hole? What is the x-axis? What will be the y-axis? Yes, please. Anyone knows here? Please unmute yourself. Don't see the table. Please unmute yourself and tell me the coordinates. Yes. So see this. So from the center to this is a what is called as adjacent side, right? This angle is 45 degree. Hypotenuse is 70 mm. This is a adjacent side. For adjacent side, how much it is? 70 into cos 45, 49.497 it is. So from the horizon, what will be the x value here? From here to here, from the horizon to center, it is 100 mm. 100 minus adjacent side. 100 minus 49.497. How much you got here? You can see the 50.503. Am I right? 50.503. Similarly, y-axis, if you go for in y-axis, total it is from here to here. Okay, whenever the session is ended, please again rejoin. Only 10 minutes time is left. Okay, from the horizon to the second hole corners in y-axis, how much it is? From here to here, it's 100. 100 plus what side it is? Opposite side. For opposite side, you can see the 70 into sine 45 means 49.497. 497 here. 100 plus 49.497 become 149.4 149.497. This is the what? The coordinates for second floor. Right? Similarly, go for third, fourth, fifth, sixth, seventh, and eighth whole locations. See that what is the whole number 1 to 8, what is the x values, and what will be the y value. X comma y you can take here. This is the what you can table. You go for construct here. Right? Yes. Any doubt regarding this? If you have doubt, please unmute yourself and ask me the question. Right? Shall I go for write the program directly? Yes, please tell me answer. Please give me answer. Shall I write
Yes,
the?
sir.
Okay. Now I'll go for write the program here. So how do you write the program? So first you go for identify the operation. How many operations are there? How many operations are there?
8.
Sorry, sir. How many operations? Now holes are 8 operations. For that to complete this model or to complete this product, get this product. How many operations? The first I want to produce a hole. The first operation is a drilling, right? Drilling operation. Am I right? What is second one? After drilling, directly go for tapping it. Just give me response. Directly go for tapping or after drilling. What is the next one? Drilling is how much diameter we're going to drill here is given only a dia is 6 mm, right? 6 mm HSS tool is given. Only I want to drill only 6 mm. After 6 mm drilling operation, what is the next step? I want to go for boring operation, right? Boring. You go for enlarge the hole. Enlarge the hole from 6 mm to 10 mm dia, right? 6 mm to 10 mm dia. Am I right? After once you go for boring 10 mm, then you go for tapping it. Tapping is what is the dia of the tapping? What is given? It is M10 into 1.5 P. Now three operations are there, right? So any doubt regarding this operation? Just please give me response.
No, sir.
No, sir.
First you have to drill the hole for 6 mm, then you go for enlarge the hole 10 mm dia, then you go for a tapping it, right? That is depend upon again operators also. After boring, after enlarging a hole, then you go for a reaming also to finish the hole also is possible. Okay, that is depend upon the operators. For my side, I'll go for take only a three operation here. Okay. Now what is the next step? Now I'll go for write the manual a part program. So how to write the manual part program? Sorry, 1 minute. Yeah. Okay, sorry. Yeah. What? So how to start the program? First, always start with the program letter O followed by four-digit number. I think anyone can tell me what is the number it is. I think it's a eighth program or ninth program. I don't know. I'll take it is ninth one. It is O0009. This is the name of the program. After the name of the program, what is the next code? Initial G codes. What are the initial G codes? G90, G21, G94. What is G90 stands for? Whatever the values, input values are given here with respect to where we are given here from with respect to horizon. See that
Origin.
what are each whole location we're going to measure with respect to from the horizon here. Origin of the workpiece x0, y0, z0. That is G90. G21, what are the input values? All the input values are in millimeter. 200 millimeter, okay, 30 millimeter, 100 millimeter. G94 means what is the feed rate is given? 40 per minute. That is the initial G codes, right? So, okay, I'll take board. After that, once you give the initial G codes, what is the next step? Then I will go for select the tool. That is M06 T01. What is the T01? What is the first operation I'm going to do here? That is a drilling operation. For this, I want to select the drill bit, twist drill bit of dia. How much? 6 of dia 6 I want to select the tool. Once you select the tool, what we will do? Now we'll go for manually. We'll go for the operator will go for
Boring.
cutting tool to the spindle, or if it is FMS is there, automatically the machine will select the tool. Sorry. After that, once you select the
Boring.
Spindle speed.
sorry.
Spindle speed.
Yeah, spindle. Now you'll go for start rotate the spindle. That is what is the code M03. Once whenever the spindle
Okay.
rotates, what is the you should give spindle speed and feed. What is the spindle speed is given? In the problem is given S is 1200 RPM. Feed is how much? 80 right? Am I right? 8 per minute. Then after this, now is spindle rotate in clockwise direction. It starts to rotate at 1200 RPM. Ready to cut the workpiece or ready to do the drilling operation, right? But where I have to do the drilling operation now? Where is the cutting tool? Now cutting tool is at the machine center point. You can see the cursor here where I am putting the cursor. The cutting tool is at the machine center. Now move the cutting tool from machine center to here to the origin of the workpiece. Now what type of code I want to give? Within the shorter distance, the cutting tool has to move. For this, you have to give rapid traverse Z00. What is X value? X0, Y0, Z always give 2 positive value, because it otherwise if you give Z is 0 means the cutting tool will come and touches the workpiece. It may damage the workpiece. For that, always give 2 away from the workpiece, right? After this, what is the next step? Now where is the cutting tool here? Cutting tool is here. Now move the cutting tool from origin of the workpiece to where? To the first location. This is the first file lines are same for all the programs. See the name of the program, initial G codes, select the tool, start the rotate the tool, and move the cutting tool from home position to the initial location. After this, now move the cutting tool from origin of the workpiece to the first hole location. So what type of motion it is? It is a linear motion. G01. What is the X value? See the table. X is 30, Y is 100, and Z value keep it is 2 away from the workpiece only. Now after this, now we immediately go for call the cycle, right? What type of operation? First I'm going to do the drilling operation, right? First I'm going to do the what operation here? Drilling operation. Now how do you call the cycle? G98 or G99. Now check here. The diameter of the drill bit is how much? The diameter of the drill bit is 6 What is the depth of the hole? 20 Whether I go for a drilling cycle or peg drilling cycle? Yes, give me answer. Whether it is a drilling operation or peg drilling operation. I want to produce a deep hole, or only the whatever the depth of hole is less than the diameter of the hole, or depth of hole is greater than the diameter of the hole here. Depth of hole is how much? 20 Diameter of the hole is
6 mm.
6 means I want to go for peg peg drilling cycle. What is the peg drilling cycle code? G83, right? G98. After the G83, what is the block for G83? R Z